Today we'll be taking a look at a very special operating system that many of you have been requesting I make a video on, TempleOS. This is a public domain operating system built 100% by Terry Davis, who passed away 4 years and 1 day ago. And he considered this to be his greatest work, and it really is an amazing feat of programming. It's probably one of the most impressive programming projects ever done by a single person. In fact, I would say it's more impressive than a lot of projects that dozens or hundreds of people have collaborated on. So to give you a little bit of background into this project, Terry Davis says that he was chosen by God to create this. TempleOS is supposed to be God's third temple, and there's a lot of biblical references that you'll probably pick up on as we take a look into it. But God had some very specific build specifications for this. The entire OS had to fit within 120,000 lines of code. And in order to meet those build specifications, Terry developed his own programming language and his own compiler called Holy C and the Holy C compiler, respectively. So that's what this is built with, as well as some x86 assembly. And he used these tools to create his own file system called the Red Sea file system. He created his own kernels, his own utilities, his own graphics libraries, his own libraries for everything, sound libraries, etc., programs, and even games. So when I tell you that he created his own OS from scratch, he really did. This isn't like Linux from scratch where you take a bunch of things that other people have built and put them together like Legos. This is like going out into the woods, chopping down a tree, turning it into lumber, and then building a house with it. And the operating system itself is really nothing like Linux, Windows, or any other modern desktop system. Terry described it as being like a modern day Commodore 64. The graphics are all 640 pixels by 480 pixels, 16 color, not 16-bit, but 16 colors. And the entire operating system, kernel, user space, everything runs in ring 0. So you have full control of it. And there's no root, there's no sudo, no separation of privileges or anything like that. So why don't we just download the ISO and get into it from TempleOS.org and take a look at how small this is, right? 16.5 megabytes. That's the entire operating system, which is smaller than almost any browser I can think of. It's even smaller than most text editors that I can think of. And of course, this has its own text editor inside of it. Now, I'm gonna be running TempleOS inside of a virtual machine. This is similar to how Terry ran it. He ran it, I believe, in VMware on a Linux host. I'm gonna be running it in Qemu. But it is possible to run this on hardware if you have something that's compatible. I've seen people run it on like old ThinkPads and things like that, like I think a T60. You're not gonna be able to run it on bare metal if you have a newer system, I believe, because of changes to CPU instructions. But yeah, this is just how you do it for Qemu. So you want to export the audio like this, create the QCOW image, and this is the main command. So we're creating a 64-bit virtual machine because this is a 64-bit OS. Sound hardware you want to be PC speakers or the voice of God, I think is what Terry called it. That's the only way you're going to have audio. And for memory, give it 512 megs for the installation, enable KVM, and then just specify, CD-ROM and the TempleOS ISO. Oh, and before I actually boot into this, just a quick warning: TempleOS, the user interface has a lot of like bright flashing lights and blinking and things like that. So go ahead and pause the video, take like whatever precautions you need if you're sensitive to that. All right, so this is how we boot up. It instantly boots up. Okay, no Linux disk or anything. Linux Live CD is ever gonna boot this fast. Already kind of messing up a bit. Full screen it. All right, so we'll install it to a hard drive before we get into any of the fun stuff. And yeah, we're installing to a virtual machine and then hit enter. So this is going to do its thing. This is always what it's going to tell you, but you don't have to install it. Like, I just wanted to kind of show you guys the installation steps. You can run TempleOS from a live CD if you want. And this isn't going to take very much time at all. It's going to install faster than any Linux distribution, even definitely faster than any Windows or Mac OS, anything like that. Okay, and we're finished. I was about to say, I know from the last time I installed it, when it does the Bible thing is one of the last things it installs. So reboot now. We're gonna say no, just because it's a different command to boot it for Qemu. So we'll go out of full screen and. Oh, by the way, so in Qemu, it's Control-Alt-G to release your mouse from the VM, but I've just found that it doesn't always work in full screen, so that's why I do Control-Alt-F and then Control-Alt-G. So we'll quit, and then we'll go ahead and run it from the QCow. So here I'm allocating 32 gigs of RAM and 16 threads. And then this is what you get when you're booting from hard drive. So it tells you to choose the drive. So we'll just do 1 for drive C. And it's uncompressing the dictionary. There's a built-in dictionary, and there's also a built-in Oracle, which we'll take a look at a little bit, like sort of a random word generator, and that's what Terry used to talk to God, or at least one of the ways that he talked to God. So anytime you start up TempleOS, you're going to get this take tour, which is really good that Terry built this in, because obviously looking at this, it's one of those things where you can sort of just get lost really easily, and I probably still will get lost. But let's take the tour to try to understand what we're doing. So part 1, the help system. All right, so press F1 for the main help index, and that works both in the editor and at the command line, so almost everywhere. So that's good to know. F1, definitely something we'll have to remember. So let's go back to it and take the tour. We'll bring us back into this. Let's go through the basics. So we're at the command line again, and the syntax is like C or C++, except you don't need parentheses if there's no arguments. So even though we're at a command line, we're not going to do any shell scripting. Okay, there's no bash, there's no ZSH. That's I guess bloat in God's temple. Everything is going to be using C syntax. So if we want to do basically an ls, this is the equivalent, dir with the semicolon at the end. And Control M will help us access our personal menu. So this is like our start menu. And you can see all the stuff we have down here, lots of fun games. And you can also get to your personal menu by clicking on the word menu in the title bar. So I assume this is what they're talking about. Okay. And it wants to press cursor down 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Keyboard commands are space for left action, so that's kind of the same as left click. Enter for right action or right click. Escape is save and exit. Shift escape is abort and exit. Okay, probably going to get those two backwards. Escape, save and exit. Shift escape, abort and exit. Okay, and the cursor is now on top of a macro that we wish to run. Press space, so we're going to run this macro right here. And what that did is it changed directories. So you can see this is how CD syntax works with a parentheses, a double quote, and then the double colon. So it's telling us, well, I guess this is what you have to do before. Yeah, so double colon, it basically means like C in Windows. So you could do like D colon, right? So that this is almost kind of like a Windows thing. But the double colon will just tell it to go to the root of whatever drive you're in right now. And then from there, it's pretty much standard to specify directories. And you got to make sure that you close the parentheses and include the semicolon. And then dir is, of course, like just LSing this. So the red are file links, and then left clicking is gonna edit or open them. Well, both. Open, but also be able to edit. And then right clicking or pressing enter is gonna bring up a menu of options. So I guess I can do like that, or none of those have options. Okay. And these are macros that'll just change directories. So presumably this will go up a directory. Or, oh, I guess I have to actually like run that. So, oh wait, that's right, I'm in the demo. It won't like let you just freely use the command line in the demo. Okay, whatever. Control T, toggle plain text mode. All right. And DOLE doc widgets are bracketed with $, characters, LK stands for link, MA stands for macro. And then Control T to go back to regular mode. All right, so that's good to know. The basics, this one, if I remember correctly, just kind of walks you through some basic command line moves. I could probably just show you guys that. Let's see, I think this is a scroll. No. I think, oh, didn't want to do that. Okay. We can just do this works to bring us back to a terminal. And I believe Control-Alt-T also does it. There we go. Finally, something familiar from a Linux distro. Terry was so kind to include that for us Linux folk. All right, so we're here in our home directory. Oh, I did not want to go into that. Okay. There we go. Here at the home directory. So what did we go over? We said that dir is sort of like the equivalent of our ls. Doc clear is like the equivalent of our clear. And ed is the name of our text editor. I'm not sure if this is the same as like ed, the standard text editor on Unix systems, because unfortunately I'm not familiar with that ed. So anyway, let me just show you how to create a file. So again, parenthesis quote, and we'll say hello.cpp.z. So this isn't just a standard like text or document, and then we're gonna put a colon at the end. And then, yes, that's okay. So it seems like the syntax is a lot harder, right? Like if you're used to bash, but in some ways, the syntax is a whole lot simpler. So let me just kind of walk you through how to do hello world, all right? If we were in Python, hello world would be like this, right? And yeah, you don't need the new line character. So like that's hello world in Python. Hello world in C is a little bit more convoluted. So include stdio.h, and then we have to define a main function, and we got a printf hello world, and do a new line at the end. Well, you don't have to do the new line, but you know, it looks ugly if you don't. Because yeah, you can't even do printf without this include stdio. And then we gotta let it know that it's done running. Return 0, and then close off the main function, okay? So that's what, 5 lines of code to do hello world in C? Let me show you Hello World in Holy See. That's it. So you don't have to include stdio because that automatically gets included. Like when you're typing out at the shell, you're feeding right into a Holy See compiler. Okay, so that's already included. stdio or whatever the equivalent that Terry created is already included. And anytime a string is found inside of double quotes, it's automatically going to be sent to printf, or at least Terry's equivalent printf. So you don't even have to tell it to print. All right, and same thing with the main function. So automatically, the main function is just created for you. Like you don't have to, do the int main, all of that. So we'll save it, and try to remember how to run it. So it's include, and we don't use parentheses when we're running something. hello.cpp.c and parenthesis or semicolon at the end. But you see that? Hello world. All right. So in some ways, the syntax can be a whole lot simpler. What else is there that I could show you at the command line? We can do task rep. So this is kind of like a task manager. All right, and it tells you what tasks are running on each CPU. And if you pay attention up here, so this is CPU 00, the first one, and the first task is Atom task. And then below it, these are some of its children. So like there's task rep itself is running here, window manager, and I think all these like Seth tasks. I'm not sure what this is. I think maybe it just means that nothing is running. Not entirely sure, but what I do know is this Atom task. So the reason this is first is because it's the first thing that runs on your system. So you can think of Atom as sort of like the init task, like the equivalent to an init task on a Unix system. So that's another Bible reference, right? Adam is the first man, so it's also the first task, and then every other task that runs below it is a child. Now, the last thing I'm going to show you guys is kind of how the documents in TempleOS work, or at least just a basic understanding of it. Let me do a doc clear again. So I think it's in, let me just do this. I know it's not the most efficient way, but that's fine. This is also Adam's folder, by the way. So this is where all of, that's where all the stuff runs. So cd into demo, and wait, no, / demo games, I think is the directory. Yep. All right, so run a dir. And let's take a look at, it's kind of hard for me to read files with this layout. Castle Frankenstein. All right, let's go into that one. So ed, or wait, I gotta do this. C.C. All right, so this is a game that we just went into, and the source code of the game is here, but also you've got these sprites. So these are like little monster men that you can fight in this game, and you've got the map. This is the map right here. All of this is written directly into the source code of the file. Look at this, 3D sprites in the source code of the file, okay? So like, I know some of you are watching and maybe don't know anything about programming. If you were to make a game, or if you were to code anything, not even a game, like anything that's gonna have images in it, those usually get loaded as separate assets from a separate folder, a separate file. You know, like if you've ever poked around in your game files before, your sprites are gonna be in a totally different area from the actual logic of the game. And you can see how small this game is. Like, let's see, can I scroll? Okay, yeah, I can scroll. This is only, okay, we have a line count down here. This is 570 lines of code, including 3D sprites. And this is actually a 3D first-person shooter. All right, so if I, let's see, I think Shift Escape, and then, can I just click it to run it? No, that's to open it. I think maybe I can just type, oh wait, no, maybe I do this. Include Okay, that's not how I run it. Okay, I can do this to run it though. It's all good. So it's a game, which means it's going to be somewhere in here. It's considered an unfun game. And let's see. It seems like you guys aren't able to hear sound. Let me see if I can fix that. Okay, I think now, yeah, you guys can hear sound now. Let me just adjust this. Okay. I should have made sure OBS had my desktop sound before I started recording. Alright, so arrow keys to move around, I think space is to shoot. So kill that guy. I think there's a dude that like hangs out down this hallway. He might come out and try to kill me. Yeah, I don't really know what the like idea was behind fun games and unfun games. I don't know. I mean, he made like 20 games. And I think these have collision, right? Yeah, I can't go through walls. So there is collision. It kind of seems like there's not, like it seems like I'm no clipping, but this is just like a camera angle thing, which that's not even a big deal, because AAA games will have bugs like that. And obviously they will be monstrosities of code, right? Like, if you've ever installed like Call of Duty or GTA, you know, those are all like 50 gig games. This is the whole thing. Oh snap, that guy like went in a river. I can't walk on this, they can though. That dude's dead. I think there's only 2 more of these guys left. Oh, going the wrong way. And again, all of this, the sound, well the sound is PC speakers, which it's funny because they technically only have like on and off. So you have to do like a little bit of a trick to get it to sort of sound like it has these different pitches and stuff. Anyway, game completed, right? That's a whole game that, again, is like just a few lines of code, a few hundred lines of code, including the sprites, the map, the game logic, everything. And it's not even like it's full of bugs. It's brilliant. So remember how I was telling you Terry had an oracle that was built into this, sort of like a random number generator that let him talk to God. And show you that if I can get a handle on this. Okay, so let me look at my notes here. F7 is the God word. Okay, so this just gives us random words. So, cometh, shade, refuge, beganest, her, defective, unchanged, heretics, master, search, meditating. Okay. I'm not really sure what any of that means. Terry was obviously able to garner something from this. Shift F7, looks like that gives us a God passage. So let's see. I think this is a passage from the Bible. Yeah, Luke chapter 7, verse 29. And all the people that heard him and the publicans justified God, being baptized with the baptism of John. But the Pharisees and lawyers rejected the counsel of God against themselves, being not baptized of him. And the Lord said, whereunto then shall I liken the men of this generation, and to what are they like? They are like unto saying, we have piped unto you, and ye have not danced. So yeah, I think this is King James Version. It kind of reads like that, sort of like that old English style. So think of the brilliance of this, right? There's a whole Bible embedded into this operating system, and you can randomly access passages and things like that, sort of like Bible apps, right? Maybe some of you guys have a Bible app on your phone, but is your Bible app 16.5 megs? Is it bigger than that? It probably is, right? And you probably can't play games or embed 3D sprites into the game files from your Bible app. Okay, so just how much is packed in here and how much space is absolutely brilliant. Let me shift escape out of this. Oh, came back to this screen. I believe I can click this to pop a terminal too, right? Yeah, all right, that's a little nice and comfy. What else do we have? We've got the God Song, which is F6. I'm not sure how to drive this, so maybe we won't end up using it. The Holy Spirit can puppet you. Press OK to generate a random number from a timer. Okay. Yeah, I'm not really sure how to operate that, so just quit out of that for now. Let's see, Shift and F6 is a God doodle. So let's see if we can get God to draw something for us. Press space until it finishes. Okay. All right, so this is God or the Holy Spirit. Well, I guess they're the same thing. Drawing for us. And this is all just like randomly generated. It's kind of cool. I mean, it's, oh, okay, press escape to insert sprite, shift escape to throw away sprite. So this sprite that we just created, we could insert this into a game, right? Like this is sort of, I guess, how you would make sprites in TempleOS. I'm going to shift escape because it's not really anything I can do anything with. I think that this might be good for just a basic introduction. As you guys could probably tell, I got to play with this more to really show off to you like what to do. But I just wanted to bring some light to this project. I know other people have talked about it in the past, but I don't think a lot of people seem to just really focus on the man himself, right? Terry. They're like, oh, he was a schizo that said the N-word. Ooh. But this is what really matters, right? This operating system that he created by himself, mind you, because it's brilliant. And I probably, because I'm not really an expert in C or systems programming, so I can't even really explain how brilliant a lot of these things are. There's probably other people, or you could even find re-uploads of Terry's videos on different YouTube channels that go more into depth explaining it. As far as benchmarking things, it's going to be much faster in TempleOS. Like if there's anything that runs in TempleOS as well as like Linux or Windows, probably any like C programs, they're going to be way faster in this because everything's running at ring zero. There's not a whole lot of computational bullshit you have to go through. It runs as fast as it possibly can. There was a video, I'm going to see if I can find it to put so that Terry can actually explain it instead of me trying to quote him. But he was giving an analogy of his OS and comparing it to like Linux and Windows. And he was saying that Linux is kind of like a semi-truck. There's all kinds of extra knobs and dials that you don't see in regular vehicles. And it kind of makes Linux a little bit more difficult for, I'd say, maybe the normal human being to run. And then I think Terry compared Windows to a car, like a sedan, and TempleOS, he says, is like a dirt bike, right? Or like a motorcycle. It's very lean. It's responsive, right? If you lean to the left or to the right, a motorbike's going to move. A car is not, certainly a semi-truck won't. And because of that, right, there's not a whole lot of safety precautions built in. It's not going to stop you from doing something. So if you lean over too far, you'll crash. Just don't do that. But this is your introduction to TempleOS. Hope you guys enjoyed it. Be sure to leave a like and a comment to hack the algorithm, and have a great rest of your day.